Okay, hello and welcome to another session of 10 minutes of learning. In the last two problems, we had dealt with RC circuits only. Now, this problem will be about RLC, that is a more practical approach to whatever we have been studying till now. So, a voltage is given by, as usual, we'll be jotting down the given values and doing a minor analysis on it. So voltage is given by 100 sine 314t. That means Vm is 100 and omega is 314. The resistance is given as 10 ohms. You can see here 10 ohm resistance. Uh, L is given as 0.0318 Henry here, and C capacitance is given to be 63.6 into 10 to the power minus 6 farads. Microfarads is given. You need to calculate the expression for I. That means this was V. We need to find out. Let's take another color. We need to find out I. The expression of the I. That means in this form, we have to find out plus minus theta. We have to find out this theta. We have to find out Im. Then we have to find out the phase angle between voltage and current. Obviously theta we need to find out, and the power factor, that means obviously cos theta we need to find out, and the active power consumed, that means P, which is Vi cos theta. So this looks easy. It's basically we're going to start this solving this. So first, how to approach the problem. You can see that uh, if omega is 314 radians per second, then we can calculate xl and xc from the L and C values given. So first let us do that, because without that we won't be able to calculate the Z or the impedance, and if we don't calculate Z we won't be able to find out the value of I by applying Ohm's law. What I just said, I will just write it down. We need to find out I, which is equal to V by Z, and V is given, Z is not. V is given, Z is not. So for finding out Z, we need the values of XL and XC, because Z is whole root over of R square plus XL minus X square. So XL we need to find out omega L, and XC we need to find out 1 by omega C, right? So if you do that, I'll just give you a quick uh, answer. Omega is given as 314 already. L is 0.0318. So should be something here. Just calculate in a bit. And this will be 1 by 314 into 63.6 into 10 to the power minus 6. So finally XL will be and XC will be, let me calculate the values and write them down for you. So I've written the values of XL and XC. XL is 9.9852 ohms and XC is 50.074 ohms. You can see from here XL is less than XC. So for this expression, we can safely assume that this is an overall capacitive circuit where the final current will be leading the voltage. Okay, how is that obtained? Let me just give a small recap of the phasor diagrams that we had learned in one of my videos. If this is the voltage vector, the current due to XL will be somewhat here because XL is small, the current will be higher, and XC is large. I'm sorry, sorry. This is the voltage vector. This is the inductive vector. This will be the capacitive vector. You can see that this will be higher than this. As a result, it will be something here. That means the entire current RLC will be somewhat in the positive direction. That means leading. Okay. So let us go ahead with the problem. So first we need to find out the value of Z, right? So Z will be given by root over of R square plus XL minus XC whole square. Okay. So whatever the values that you have got, if you do that from here, that means the value of R, value of XL, the value of XC, it will come to 10 square plus 9.9852, 9.9852 minus 50.074, 50.074, the whole square of that. So this basically comes to 41.317, 41.317 ohms. Okay, so this is the value of Z that we have got. Now calculate. Okay, just a minute please. So this was the value of Z. Now let us change the color a little bit, do it one by one. So for I, we know that V by Z is your formula. So V is given as 100, where V is equal to Vm. So our first target is to find out was to find out Im. So if you represent this by Im and Vm, then simple 100 divided by 41.317, this Im comes to 2.42 amps. That is the maximum value of current. So in this, for this expression, we have got the value of Im. Now what remains? It remains to find out the value of theta. So theta, how will theta be found? It will be the cos inverse of base by hypotenuse, or cos inverse of R by Z. If you remember from the impedance triangle, the impedance triangle was a right angle triangle, from where we found out that theta is basically cos inverse of the base by hypotenuse, that is R by Z, or the resistance versus the total impedance. So let us find out the value of theta. Cos inverse of R is given as 10 ohms, right? And Z we have found to be 41.317. The cos inverse, it will come to approximately 76 degrees. It will come to around 76 degrees. I have already done it, so that's why I can say it directly. So the value of I, instantaneous current, which is in the format of Im sine omega t plus theta, is given by I equal to 2.42 sine of 314 t plus 76 degrees. This will be your final expression for I. Yes, it's clear. This will be a final expression of I. Okay, so that's one part solved. Now let us go to the next part, phase angle. I guess phase angle we have already found out, that is 76 degrees. Theta is 76 degrees. Leading or lagging, we have already find out XC is greater than XL or XL is less than XC. So that means 76 degree it will be leading. The third thing, phase angle between the voltage and current. Oh, this is found out already. The power factor. Power factor is very simple. Cos theta, which is equal to cos of 76 degrees. That is be around 0.24 leading. That is another answer that you have got. And finally, the active power consumed. Very simple. P is equal to V into I into cos theta. It comes to the next slide, or shall we continue in this slide? P is equal to V into I into cos theta. Now, I think we need to go to the next slide because there is a small concept we need to make you understand. So, P is equal to V into I into cos theta, which is a very common expression. This is basically nothing but the V RMS, I RMS, and cos theta. Okay. Now, in these expressions, whatever V we are considering here, this is Vm. Again, here this is Im, this is Im. So, for converting the Vms and Ims into RMS values, you just have to do divided by root 2, divided by root 2 into cos theta. So, Vm was 100, so 100 by root 2. Im we found to be 2.42, 2.42 by root 2, and cos theta we found to be 0.0, sorry, 0.24. So once you do it, the final result will be approximately 29.16 watts. That will be your final expression for power. Please guys remember to do this conversion from VM to VRMS or IM to IRMS. Please do not forget it because that's a very important thing to do while solving a problem like this. Okay. See you in the next video. Have a good day. Bye bye.